Hey everyone, and welcome. Today, we're going to pull back the curtain on the whole world of design and manufacturing. We're going to break down exactly how that awesome idea in your head can become a real product that you can actually hold in your hands. You know the feeling, right? Especially if you're a design student. You're looking at your project, maybe it's just a sketch or a rough model, and you're thinking, how on earth do I get from this to that polished, professional product on a store shelf? It feels like this massive, impossible leap. Well, here's the big secret. You're actually already on the right path. Seriously. The process you're learning in your design class right now, the steps you're taking for your own projects, that is the exact same fundamental blueprint that powers everything from a one-off custom piece to products sold all over the globe. Okay, so let's dive into what this blueprint actually is. And this isn't just some boring theory either. This is the practical step-by-step framework that designers rely on every single day, no matter what they're creating. So here it is, broken down into 6 key stages. You start by defining the problem you're trying to solve. Then you get into research, brainstorming, and experimenting with prototypes. Then you refine it, finalize it, and finally, produce and market it. But here's the most important part, the real pro tip. See that last step, evaluate? It's not just something you do at the very end. Great designers are constantly evaluating at every single stage to make sure they're still on the right track. So now let's look at how this blueprint plays out in the real world. Because while the core process stays the same, the setting and especially the scale can change absolutely everything. Level 1 is where so many amazing creators get their start. This is the domestic setting. Think of a baker making incredible custom cakes from their kitchen. Or maybe an artist selling handmade jewelry at a local market. We're talking small scale, often a one-person show using pretty basic tools to create unique things for a specific customer. Next up, we level up to the community setting. Now, the big difference here is the goal. It's not about profit, it's about the common good. You might see this in a community garden that provides fresh local food or a small co-op that's focused on creating jobs in the neighborhood. It's all about using design and production to serve a shared purpose. And then you have the major leagues. This is the industrial and commercial setting. Now we're talking about massive factories, really sophisticated machinery, and a huge workforce. The goal here is simple: to make a ton of product, do it efficiently, and be commercially successful. This is all about scale and profitability. This chart just lays it all out so clearly. As you move from left to right, from domestic to industrial, you can see how everything just levels up. The scale goes from one-off to massive. The tools go from basic to super sophisticated. And the funding required, it goes from pretty limited to, well, significant. The goals change too, shifting from a single client order to the community's good to mass market profit. So how do you even make that jump from a small project to an industrial scale? The answer, in a word, is technology. You can think of these tools as the ultimate power-ups, letting designers work faster, smarter, and bring incredibly complex ideas into reality. It pretty much all starts with CAD, which stands for Computer-Aided Design. This is basically the digital drawing board of the 21st century. Instead of sketching on paper, designers build these incredibly precise and detailed 3D models right on the computer. And the best part, you can tweak and perfect these digital blueprints with just a few clicks, which saves a ton of time and money later on. Okay, so once that CAD model is perfect, the data gets handed off to CAM, or Computer-Aided Manufacturing. CAM is the essential bridge that connects the digital design to the physical factory floor. The software basically reads all the data from the CAD file and then creates a set of instructions for the machines that will actually build the product. And who's following those instructions? That would be the CNC machines. CNC stands for Computer Numerical Control, and you can think of it as the hyper-precise brain that guides all the factory machinery. It uses complex math to control the cutting tools with just unbelievable accuracy, making sure every single part is made perfectly, exactly as designed, thousands of times over. But, it's not all sunshine and robots. This slide really shows the two sides of the coin when it comes to technology in manufacturing. On the one hand, the benefits are huge. It's way more efficient, things get made faster, and it's often safer for workers. But there's a flip side. The setup costs are enormous, it can unfortunately lead to job losses for unskilled workers, and the environmental impact of industrial pollution is a really serious issue. It's a trade-off that has to be carefully managed.
All right, enough with the theory. Let's see how all this stuff, the blueprint, the industrial scale, the tech, all comes together in a real product you might even have in your own kitchen. We're going to follow the journey of the Breville citrus press.
And this is where it all began. This is step one of that design blueprint: define the problem. Breville's designers saw a need in the market for a really good high-end juicer, and they came up with this simple, clear goal: maximum juice with minimum effort. That one simple phrase became the North Star that guided every single design decision they made from that point on.
And as you can see, this was not an overnight success. The process kicked off way back in 2004. It won its first big award a year later, and get this, a decade later, an updated version was still winning awards. This timeline just goes to show you that a really strong, well-researched design can have incredible lasting power.
Now, to actually build this thing, they couldn't just use one simple process. It took a whole combination of sophisticated industrial techniques. The parts were all designed in Sydney, but they were produced over in China by a team of up to 500 people. They used die casting for the sturdy metal body, injection molding for all the plastic parts, and this really complex metal pressing process for the stainless steel bits. So after all that design, all that prototyping and testing, it was finally time for the big production run. A standard assembly line for a product like this can churn out about 500 juicers a day. So for their initial launch, just in Australia, Breville's target was around 10,000 units. Now that's the power of industrial-scale manufacturing. Okay, let's bring this all back home, back to you and your design projects. Because the big takeaway here is this. The whole process we just walked through, from spotting a need, to prototyping, to understanding how things are actually made, that is the exact same process you're learning in school right now. Sure, the tools might be different, and the scale might be a lot bigger, but the fundamental thinking, the core blueprint, it's identical. And once you understand that, you have the power to take your own ideas, even one that starts as a simple sketch in a notebook, and turn it into something real, something useful, something amazing. So the only question left is, what are you going to build?